Hello. In this video, we're going to apply product and quotient rules to find derivatives of more complicated functions. I'm actually going to run you through the proofs of these rules in class, but for what we have here, if we have a product of two functions, so f times g, the derivative of that function with respect to x is the derivative of the first function times the second function, plus the first function times the derivative of the second function. And there's a similar rule for quotient. If I have a function that is a quotient of two other functions, derivative of the first function times the second function minus the first function times the derivative of the second function, all divided by the denominator function squared. And again, I'll prove these to you in class, but let's look at what it looks like here. So I have y equals 3x squared plus 9 times the square root of 5x plus 6. So essentially, if I say my first function is 3x squared plus 9, and my second function is the square root of 5x plus 6, but I'm going to write that as a power, so 5x plus 6 to the power of 1/2, then y equals the product of f and g with respect to x. So I can apply the rule here. I'm going to derive the first function, so dy dx equals the derivative of the first function, which is 6x, times the second function just as is. And I'm sorry, I am going to leave it as a power. If this will let me erase. There we go. So 5x plus 6 to the power of 1/2. I have not derived it. I've left the second function completely alone. I derived the first function and I just copy the second function. Plus, now I just write the first function, 3x squared plus 9, not the derivative, just as it is. And now I'm going to multiply by the derivative of the second function, which is 1/2 times 5x plus 6 to the power of negative 1/2 times 5. Don't forget the chain rule here. So I am going to tidy this up a little by factoring out any common factors. I'm also going to factor out the fraction of 1/2. So the common factor, I'm going to use the lowest power of 5x plus 6, which is to the power of negative 1/2, and I'm factoring out the 1/2. So 1/2, 5x plus 6 to the power of negative 1/2. And what I get when I divide by that. So 6x, I'm going to divide by 1/2. That gives me 12x. And 5x plus 6 to the power of 1/2 divided by 5x plus 6 to the power of 1/2 leaves negative 1/2, leaves me with 5x plus 6 to the power of 1. And then plus, I still have a 5, and I have 3x squared plus 9. Now I do want to tidy up what's in these brackets here, but I'm going to move the first two parts into the denominator. So dy dx equals, I'm going to have a denominator here of 2 times, at this point I can switch it back into a square root. You don't have to, you can leave it as a power if you like. And in the numerator I have 60x squared plus 72x plus 15x squared plus 45. So we have 75x squared plus 72x plus 45. And there we go. There's the derivative. Now let's look at a quotient. And we'll use the other notation. So we want f prime of x for the function f of x. Now here that means I can't use f of x to define one of my two functions because y is f of x. So I'm going to use g of x and h of x. So g of x, let's say, is that numerator function. So 5x squared plus 7x minus 2. So just as a kind of off to the side here, g prime of x is 10x plus 7. And I'm going to use h of x for my denominator, which is 3x plus 4, and therefore h prime of x equals 3. So overall, the derivative of this function is the derivative of the numerator, which is 10x plus 7, times the denominator, which is 3x plus 4, minus the numerator function originally, which is 5x squared plus 7x minus 2, times the derivative of the denominator, which is 3, and then the whole denominator gets squared, x plus 4 squared. So that's the overall thing. Derive the numerator times the denominator, minus the numerator times the derivative of the denominator, divided by the denominator all squared. I'm not going to bother distributing the denominator, but because of the subtraction in the numerator, I am going to clean that up a little. So when I distribute this binomial multiplication here, I get 30x squared plus 35x, I believe, 14x plus 21x plus 28. And in this other case, I have just minus 15x squared minus 21x plus 6. So putting that all together, in the numerator we have 15x squared plus 14x plus 34, all divided by 3x plus 4 squared. And that will be the derivative of the original function.